So hello everyone, thank you for joining in. Today we're going to talk about how the shift to the cloud has changed everything we knew about database attacks and exploitation. So today, when at least almost every usage in the cloud involves at least one data asset. It could be storage bucket, data RDS, managed databases, data warehouses, and so on. And each and every data asset has its own capabilities and features for importing and exporting data, different authentication methods, backups, replication, and so on. And when these features and capabilities kept to evolve, so do the attack landscape around them. And today attackers have more possibilities than ever to get access to your data and exploit it. But before we will dive into some technical details on how attacker can utilize this feature and capabilities, let's take a quick overlook about ourselves. So my name is Ofir Balassiano. I'm the head of security research at Dig Security. In my past, I mainly focused on low-level research, and I analyzed hundreds of malwares. Today, I'm mainly focused on protecting your data in the cloud. And with me, Ofir.
Hi, I'm Ofir Shaty. I'm a security researcher at Dig, and I have experience with web application security and database security in on-prem and in the cloud.
Yes. So what we have for today. First of all, we're going to explore Redshift attack surface and understand how Ofir and I were able to exfiltrate data and move laterally between different data services in the AWS environment with almost single Redshift permission. Next, we're going to talk about how our journey of discovering new vulnerability in GCP CloudSQL and how Ofir and I succeeded with breaking the security layer of GCP CloudSQL and get access to the underlying host. So, AWS Redshift. As we all know, Redshift is a cloud-based data warehouse, contains petabyte scale of data, and has many features for integrating with other data sources for importing and exporting data, like IAM authentication, backup, replication, and the list is much longer. But when Ofir and I wanted to understand the attack surface around it and how attacker can utilize all these features, we came across the following feature that we both thought that it's a great example of how an attacker can misuse a great feature. And the default IAM role feature basically gives you the ability to attach IAM roles to your Redshift cluster. And from now on, the Redshift cluster will be able to interact with other services in your AWS account on behalf of these role permissions. So the attack scenario we thought about is that imagine that an attacker got access to your AWS account. It could be by a successful phishing attempt or any public credentials that they found. So now the attacker got a low privilege stolen identity in your AWS account. And the stolen identity has only Redshift create plus cluster permission and IAM pass role. So now the attacker can create Redshift cluster in your account. But basically, they got access to many more services in your account thanks to this misused feature. They got access to the EC2, S3, RDS, DynamoDB, and so on. Now Ofir will continue with detailed vectors in this attack scenario.
Hi, everyone, and thank you, Ofir. So in the following slides, we're going to see some of the default role permissions, and we are going to understand how we can take advantage of those permissions in order to do some cool stuff. So we're starting with the S3 permissions. As you can see, we have many permissions like get object, list bucket, and many more. And also, those permissions are for every bucket that include Redshift in their name. Now, I want you to notice that when we created the default role, we actually chose the option of no additional S3 bucket, but still our policy got those permissions. So let's explore what we can do with it. Before we start, we are going to enumerate, to do enumeration with the copy command. But before we start, let's try to do the same with our original AWS principal. So when we run this command in AWS CLI to list all the files in the bucket, we got an access denied error. Now, let's explain a little bit what is the copy command. The copy command allows Redshift to load data from remote sources like S3, DynamoDB, EMR, or EC2. And to do so, we need first to create a table to load the data into it. So we are going to focus only on S3 buckets, but actually the same technique can be used also in DynamoDB. So we created a table called exfil for exfiltration, which also suggests what we are going to do with it. And we will use the copy command, but we will use it in different way. We will put only the path of the S3 bucket instead of using the full file name. And when we will execute this command, it will fail. But behind the scenes, when we will query a table called STL load commits, we will be able to see all the files inside this S3 bucket, which gives us a lot of information as attackers. Now we can start and exfiltrate those files one by one. So it brings me to our next attack vector, which is exfiltration. So for this attack vector, we will use the same copy command, but this time we will use it with the full file path of the full path of the file. So when we run the command, the content of the employee CSV have been loaded to the exfil table, and what you see below is the content of the table after we query it. And again, if we were using the same command from our original AWS principal, we would get some error. Now, let's continue and explore more of the default role permissions and what we can do with them. So on the screen now, you can see the Glue permissions. If you don't know, Glue service is a service that enables us to easily integrate with other data sources, like S3, for example, Kinesis, Kafka. The permissions that we got on Glue are create database, create table, and we have many, many others. And we got this permission on every Glue table or catalog that include Redshift in their name. Another strong permission that our default role got is for the secret manager. And if you ask yourself, why does Redshift need those permissions? It's simple: to connect to remote data sources. So we can connect with Redshift to Hive, RDS, Athena, and more. The permission that we got on the secret manager is for get secret value for every secret that contain Redshift in the name. And also we get a list secrets for all the secrets in our AWS account. Interesting, right? Now, remember the first restriction where we try to load data from S3 bucket with the copy command? We had a restriction. We could only load data from bucket that include Redshift in the name. But now, with those new permissions that we just talked about, we can bypass this restriction. In this following example, we will use the create external schema in order to create a schema from a Glue table or a Glue database, actually. So we are using the attack Redshift database in Glue and the lake table, which reference to the table, S3 table called Ofir Data Lake. This table actually doesn't include Redshift in its name, and we were able to access it and its data inside. So by this, we close up. So now we will see some flow diagram that shows us all the attack vectors that we can perform with the create external schema. And if you will go to our site, you can see the full attack path of Redshift in our blog, Redshift attack vectors. And by that, we close our first part for the Redshift attack vectors. And here are some takeaways. So first of all, in cloud environments, as we saw, it is very hard to answer the question of who has access to what. We need more sophisticated methods than just iterating all the permissions that one AWS principal has. In our case, we were able to move laterally with our user and had almost single permission to single service, and still we had access to data that inside many other services. And this is not exceptional in the cloud, which brings me to our next takeaway, which is reduce your attack surface. It may sound obvious, but it helps. And last but not least, monitor. We can monitor our environment in two levels. In the cloud level, where, for example, in AWS, we're talking about CloudTrail, and we can monitor in the service level. In our Redshift example, we will use the audit log. And by this, we finish our first chapter, and I move you back to Ofir to talk about some GCP CloudSQL vulnerability that we found.
Thank you, Ofir. So yeah, now we will walk through our journey of discovering new vulnerability in GCP CloudSQL. But first, let's understand why Ofir and I chose to focus on CloudSQL specifically. We both knew that GCP, like any other cloud provider, needed to implement a new security layer or any other layer on top of the classic engine in order to create managed database inside it. So in order to integrate its platform and other features. So we wanted to find gaps and holes in these new modifications that the cloud provider did. Next, SQL Server specifically, the engine, is not an open source. So we knew that GCP needed to create a security layer on top of the classic engine, as they couldn't modify the source code itself. And by that, our main research question now was if we can break the GCP CloudSQL security layer. So let's go for some basics for those who are unfamiliar with SQL Server. In general, when you create a SQL Server, it could be on-prem or in cloud, you will be created with the four default databases. The first, the master database that contains mainly system objects. Next, the MSDB database that contains SQL Server agent and scheduled jobs, and we will talk about it later. The third one is the model database that basically is a template for any other database that will be created from now on. So any modifications that you will perform on the MSDB database will be copied to new databases that you will create. And the last but not least, because it's our favorite, and you will understand why, the temp database that contains temporary objects for sorting or query results, and so on. And from permission perspective, we have several permissions that gives us the ability to operate at the server level and perform operations like create, alter, and drop on the system and the instance level, such as create new logins, alter databases and create databases, create server triggers, so alter server triggers, and so on. And in the other hand, the database permissions gives us the ability to perform operations in a database scope, in specific database. For example, create new table, create user inside the database. And these are the very basics of the SQL Server internals and how GCP implemented its security layer. In order to better understand, we had to ask ourselves some key questions. The first is to understand who are we, and in GCP, the default user we are operating with is a SQL Server user. And what is our permissions? We knew that GCP created a custom role for us, for our users, that called customer DB root role. And we knew that this role is not exist in the classic engine. And GCP created it for us. And the last, what does it mean? What does it mean to operate with the customer DB root role? It means that we are blocked. We have no permissions to the instance level, no permissions to sys objects, except some permissions to the temp DB. And basically, we can't perform any type of classic exploitation in SQL Server that we're familiar with. So at this point, we knew that we are operating as customer DB root role, and our first goal that we set is to escalate our privileges and to act as sysadmin that has permissions to the instance level. So in order to do that, we can follow some practices that helped us a lot during the research. The first one is to always understand who are we, what is our security boundaries, and what we can and can't do. The second is to enable audits. Basically, it's very helpful with understanding what is the indirect impact of our operations in the database, and understand if any background process is running with high privileges that we can utilize. Next is to always search for differences between the classic engine, the SQL Server engine from the on-prem, with the managed database one. And there we can find holes and gaps that were unexplored. So, sound easy, isn't it? Well, we tried a lot. But yeah, after some coffee shots, we came across the following screen in the GCP console, and we saw not only our user, the SQL Server user, we saw some internal SQL Server logins, and we also noticed that we can change their password, and moreover, we can enable them in the MSDB database. At this point, we knew that it was the first step towards our privilege escalation, because now we were able to move to a different permission boundaries. So, like a good researchers, we started with playing with our new permissions and created some custom jobs inside the SQL Server agents. And while doing that, we saw a specific job the GCP created called add temp DB permissions. The job runs every time that the SQL Server agent restarted, and it executes a SQL query, a simple SQL query that gives us, the SQL Server user, a control permission on the temp database. Control is the highest permission that we need in order to operate in the database. And at this point, we thought that we found it. We found a way to privilege escalation towards sysadmin. We thought that we can change the job and restart the SQL Server agent, and then the job will be running with our query instead of the original query. We couldn't do it. We didn't have the permission to do it. But instead, it gave us an idea. This job gave us, the SQL Server user, a control on the temp database. So it gives us the ability to create new triggers on the database, on the temp database. So now, the only thing we need to do is to create a trigger in the temp database and find a privileged user that will pull the trigger for us, and then our code inside the trigger, our query, will be running with the high privileged user permissions.
Yes, and so at this point, we have a database trigger in place inside the TempDB database, and we are looking for a background process that will run with higher privileges and will take some action inside the TempDB that eventually will pull the trigger and make us sysadmin. So we went back to our dearest friend, the audit log, and we went through hundreds of thousands of records until we came across this record. And what we see here, this is a very special record because we see here create user. When we created the user from the GCP console, this is actually what happens in the audit log. So this is the create user. And the user have been created in all 4 system databases, including our TempDB. And what is special about this record is that it is being performed with a CloudDB SQL root user, which is a high privilege user. So if you couldn't guess so far what we did, let's recap. We created a trigger on the event of create user that will call a function that will grant us SQL Server login with the sysadmin role. And then we created a user from the GCP console, which we know that will perform by a high privileged user that will pull the trigger and will grant us with sysadmin. Okay, so we did not get sysadmin. We got only DB root role, but this is pretty good. So this is where we wanted to get, but we get only to DB root role. Now let's inspect what actually we have with this privilege escalation. So on the left side, we can see the original privileges that we had as a SQL Server user. We have around 12 permissions, some view permissions at the server level, connect, and some insignificant alters. And after our privilege escalation, now we have a couple of more permissions, and more specifically, we have control server, which is the most strong permission that we can have on the server level. But since we are not sysadmin, we don't have full control over the server. We are still impacted by deny statements. So we still have way to go, but not for long, because look at this interesting permission. We got the permission of impersonate any login, which in turn allows us to impersonate SA. And this allows us to grant ourselves with the sysadmin permission. And in the table, you can see all the privileges or roles that we have, and also SA. So acting as sysadmin, we have full control on the SQL Server instance. And now we wanted to try and execute some code. So we have many techniques to do so, and we start trying. We tried with SQL, with CMD exec, with the SQL agent jobs, also with PowerShell. We tried CLR assemblies, and we tried with XPCMD shell. We failed with all of those because actually we discovered that we are running over Linux. More specifically, we running over Docker, SQL Server on Docker. So all of those features actually are not supported in this version. So we kept trying, and at this point we had access. We were able to enumerate all the file system. We were able to extract secrets from the operating system and read passwords. But we had a surprise. We got, at this point, we got a surprising mail from the GCP team, which asked us to stop our research. So we stopped, and we worked together to disclose this vulnerability, actually the 2 vulnerabilities. Well, we find the vulnerabilities on February, and until April, the 2 vulnerabilities have been fixed. And by that, we're closing our second chapter for the Cloud SQL vulnerability that we found. And it's time to sum up. So first of all, Google are awesome. No, but for real, they responded very quickly, and they fixed the vulnerabilities very, very quickly. And it brings me to the next thing, that the cloud brings new attack vectors to the table. In this presentation, we saw two examples for attack vectors that can be utilized in the cloud. And not everything is in our control, like cloud provider vulnerabilities, but others like the attack paths that we showed in the first part are in our scope. And the main point that I want you to take from this presentation is that in the cloud era, there are more paths to the data, and not all of them are so obvious, but attacker knows it and use it. And for my last takeaway is, it brings me to the last takeaway, that is the importance of the security in layers or in depth. We saw an example for such architecture in GCP while they implemented a Docker inside the VM, which adds another security layer. But it also highlights the fluidity of permissions in the cloud and the danger that they may bring with them. It emphasized the importance of cloud architecture and permission management. So thank you for joining us, and I hope you enjoyed the talk. And if you have more questions, you can find some interesting about this topic. You can find more information in our site and in our blogs.
That's true. Thank you.
Thanks.